Hi guys, my name is Sergey. On this tutorial we're talking about my API. At first I will show you the result of the tool that we're gonna build in this tutorial. If you're familiar with rigging, you have already see the follow problem. If I now try to set up my pole vector constraint, if I select my pole vector constraint followed by the IK handle constraint pole vector, as you see we have the flipping here. If we use this tool, I just follow the instruction here. I just select my shoulder followed by elbow, followed by elbow and wrist and control, and I press go. Now if I try to make a pole vector, if you see we have no flipping here. Okay, this tutorial will contain 4 parts. And first part we're talking about why API and how we can pick the object from viewport selection. In the second part we're talking about how we can manipulate the object, and in the third part we're talking about the vectors to achieve this approach here. If you're already familiar with vectors, you can skip this part. In the third part I will go line by line and explain you how I wrote this script. Okay, let's begin with the first part. I'm not going to go deep inside my API. My approach is just compare the MyML and Python commands with the API commands. And the first question is why API? I prepare something here, and you see this API is just this quicker, because we just through the C++ of Python we can directly speak to the API and to core of my application here. As you see here, with using the my user interface mail or Python, as normally we use with Maya command, it goes through the Maya command engine, after to Maya API, and then to the Maya application core. And therefore, as if you this is the advantage of my API. Okay. Oops. As you see, you're familiar with scripting, mail scripting in Maya. The first thing that you have to know how to pick the selected object from the selection viewport selection here. And now I go line by line and compare this mail command with Python and API ones. At first we have to create a container here. You see we have we're creating array type string, and now we use the list selection command, mail command, and put the result of this command inside of this variable. And as we know, this variable is now iteratable, and this variable returns as the array of strings. The same approach as in Python. At first we have to import the Maya commands as MC. It allows us to allows Python to talk to mail commands here. And after we create a container, you see in Python as a container's type list, and using the same command to put the string list inside of this selection. This selection container is iteratable, and this returns us the list of strings. API approach is quite the same. At first we have to import modules through Python. After we're importing the API modules, so using API commands here or objects, and after we're creating the M selection list. The only difference now is the M selection list is not iteratable. The M selection list get another types of object inside, and I cannot just iterate through my M selection list and put a name of the objects out of it. At first we have to understand what this M selection list is. As you see here, it's just a placeholder, just like an array with an index number, and we can put the DAG object inside of this array. What's a DAG object? DAG stays for as a direct cycling graph. You see the most of the object here inside of outliner are the DAG object here. Okay, and after you see this list is or this object is not iteratable. I cannot just iterate through with just like in Python or on Mel. I can not write here in a for loop for each in a selection, please print the each. It doesn't work because if I try to do this here in M selection list, it gives me an error. This object is not iteratable. Okay, now we know about the M selection list. Now go here and you see it's this almost the same. We have another module here, get selection list command, and we put with this command our MDAG object inside of M selection list. We have now here M selection list inside of M selection list MDAG paths. The MDAG paths, at first we have to understand what the MDAG path is. As you see here, we have one house with 2 apartments, and each of the apartments had a window, and the name of these windows are the same. And for Maya is very difficult to put one of them. But if we go to the house apartment 1 and pick the windows 1, this path here becomes unique. It's a DAG path. And in my API approach, we use this DAG path object to just pick the objects inside from selection or inside of Maya. It's just another approach. Okay, now if you see we have here the while loop. I just use the while loop because I would like to have the same approach here in these 3 approaches here, or in this variation. Because of this, I cannot iterate through my M selection list. I use the just number of object in this selection. It's just for better understanding of the API approach. Okay, we're using the while loop. At first we get the number of object of number of the array object, or the length of array, and just using the index we iterate through this variable on printing out our strings. If you see, if I execute this, I get the name of my selected object here. In Python it's the same. An API approach, as I said before, I cannot directly loop through my M selection list, and I have to use the MDAG path, because I can put only the MDAG path inside my M selection list. As you see, at first this M selection list has a module length, and with this length I can get the number of the object inside of M selection list, and I use this index to iterate through. As you see, at first I create MDAG path object here, and after I just get path from M selection list from index 0 into this MDAG path. That means, okay, I go to M selection list, look for the index, and put what inside of this place inside or to the MDAG path. And now you see I just use another variable in Python's type list and just take all the MDAG paths of my selected object inside this DAG path list. As you see, if I now execute this command and try to print it out, because if you see here, if I execute this guy, I can directly, not here, see what inside this variable 2, or what inside this variable as a list with the strings here. If I try to do it here, it gives me a result. I just execute it one more time and just print it out. And you see I get not a string, I get MDAG path objects. If I'd like to see something readable, I have to use the module of this MDAG path to print out the MDAG paths as a string. And you see if I execute it, now I get my DAG paths. Okay, that's it for the second part, and I see you in the third part. Now this is a time to learn about how we manipulate object with API. If you're familiar with mail or Python approach, we can use set and get address, but in this example I use the xform command. If you see, we can create a vector, and after we can pass the information using xform query world space transition of this first object of the selection, and we're passing this result inside of position variable here. You see the result is 0, 12 and 0 here, and you can print the component 2 if you would like to, and you can set, if I zero this out, I just can set with the xform, you know, as you see here I set the transformation on translation of this object to 0. And Python is the same approach here. In Python we have no vectors, we're using the tuples or lists with 3 components here, and using the xform command just like in mail to move object or to get the transition value. And my API is just a little bit different, because if you see here, as in this example, this classic object-oriented programming approach versus my API approach. In classic approach, we have one class that handles the data and function. In my API approach, we have two classes. One handles functions, and the next class handles the data of the object. Okay, at first you have to create a function set, and after you have to set the function set to this object in order to manipulate data of this object. Now we see it how we can script it. As you see here, I use the MFN transform, or I create MFN transform a function set in order to manipulate this object DAG path object. This DAG path object is linked to my selection here. Okay, to better understand what the functions or what commands or what methods has this MFN transform function set, we have to use a help. If you see here, we have here my developed kit and the function set MFN transform. When you see, we have all kind of modules here, and you see we need two of them, set translation and translation. And that it says set is for setting translation, on translation is just for getting translation. If you have to get more info about the parameters of this module, you just have to click on it, and you see this set translation. The parameters are mvector, and the second parameter is mspace. This is constant, and if you click it, you see this is just like arguments in my mail or Python commands. If you see here, we have, for example, number 4 is for world space, for transform, form object, space, and something like that here. I'll go back here, and we have a constant. We just need a 4 here, and we have the m vector object. If you click on it, you see it will there is explanation how the m vector object works here. And you see in my example, at first we have to create an m vector object using Maya, OpenMaya module, and after we just for setting transformation, we need the value here and the number 4 for world space. And if you would like to get a translation, I need the same m vector object to get the translation. On this translation, if you see in the help here, if I go to the translation, you see the arguments. We have just one argument, is this m space, and we know already about this is number 4, and we just can bring it and get the translation values inside of this m vector. Okay, we'll try it now. As you see, I just take this guy and execute. we get the MBAC path here, and you see we can now put the translation value inside it, and you see if I print the values here, you see we have the 0, 12 as we see here. And for setting transformation, we just use this guy here. You see I just take 0 this out, you see the numbers are 0, 0, 0, and now I can set the translation as you see on the first object. If you try to do the undo for my API commands, it will not work, because for my API you have to code your undo command. If you see, if I do Control Z, oops, it goes back now. I try it again. And you see we cannot do the undo here because it's not undoable. As you see, I tried and we cannot do undo here. Okay, that's it for this part, and I will see you next part with the vectors. It's a vector time. What is a vector? A vector is a quantity or phenomenon that has two independent properties, magnitude and direction. If it makes no sense for you, I just show you in this example what the vector is. You see the vector has a direction and the magnitude is defined by its length. What can we do with the vectors? We can do some addition, subtraction, multiplication. We can get the magnitude or length of a vector. You can make the vector normalize or unit vector, and dot product and cross product. It's not for this tutorial. This tutorial I just share in two parts. The first part is 2D representation of the vector for simplicity's sake, and in 3D explanation I will talking about my mVector class and the modules coming with this class. Okay, now we have to create our first vector. I open a new scene and we go to the front size, because we will be working in two-dimensional space where the epsilon is pointing up and x is pointing to the right. For creating the vector we need a point, and you see I specified here two lists. This is my x position, epsilon position. I just execute these two guys, and now I just use the locator, and these 4 lines I just create locator, get the shape and override the color, and move the locator to the given space. As you see, I take this vector A and put here, and you see if we execute it, we get the point here, and this point is exactly 1 unit and x and 2 unit and z. An epsilon, sorry. Okay, just get this position too to get another vector here. And you see we get another point here. Now we create a vector. If I take my curve tool here, set the curve degree to 1, and using snapping tools I just create one line, and now I just get this tool again and create another line. And you see we get the two vectors. Vector B as this guy, I think, and vector A is this guy. Now we'll do some addition. We would like to add vector B to vector A. How can we do this? I just take my vector B, and as you see, the vector has the beginning and the end, and then I just take the beginning of my vector B and put it to the end of the vector A. We just snap it, and you see we get the new point. And if I execute this line and just take this value and just create a new point, as you see, we get the point exactly in this position here. And if I now draw the line here, we get the vector sum here. Okay. In this case, as the orders doesn't matter, I can take vector B and apply it to vector, or add it to vector A, or vector A to vector B. The result is always the same. In this case, the order is very important. I show you what I mean. At first, I will subtract vector B from vector A. I just take this guy and delete it, and put my vector B to its to its original position. And now we just take vector B, and instead of put the beginning to the end, we have to put the end to the end to get the different. Okay, I just move the pivot point to the end here, and now I snap my vector B to the end of the vector E. And you see I get a new point here. If we execute this guy here and use this variable to create the new space locator, we get the point exactly on this place here. If I draw the line here, we get now the vector BIF okay. And now we try to do the opposite. Now I take the A and subtract it from B. I put my A back. Now I take the A and I subtract it from the B. We have to position the pivot point, and I take the end of A and put it to the end of the B. And you see we get another point here. And if I execute this line and take this variable and create locator, we have it already, we get a point on this position. And if I draw the line, we have this vector. Okay, what about multiplication? If we multiplied each component with a constant value, here if you see, with multiplying vector A with 2, we get another vector looking in the same direction, but the length or magnitude of this vector is twice long, or it's twice multiplied by 2. Now I show you what I mean. We're just taking back the vector E to the origin. I just delete all these guys. These two. These two. Okay, we make some multiplication, and I create the new point. And as you see, if I draw the line now, we get the vector pointing the same direction, but the length is twice longer than this one here. Now how we can get the magnitude of length of this vector. I just take it away. With this formula, we just take the sum or square root of the sum of the power of each component by 2. If you see, I use the math module of the Python, and if we execute this now, you see we get this number here. I just copy it here. Enough. Now if I take my measure tool and just measure the distance, you see we get the same number here. I just delete this guy. Oops. Okay, what is a unit vector or normalized vector? The normalized vector is the vector pointing in the same direction, but the length of the vector is equal to 1. We just take the vector E and just normalize it. As you see here, I have a formula here. It's a little bit more complicated here, but don't be afraid, because if we will when we work with m vectors, there are some modules, and we don't need this formula anymore. But now I just execute this formula or this line, and I create now the point. And as you see here, we get a vector now. And if I take the measure tool and just measure the length, you see this vector has a length equal to 1. Okay, that's it for this part, and I will see you in the next one. And we're talking about m vectors or m vector class. Now we'll talk about m vectors. As you see, I just import Maya OpenMaya is OpenMaya, and I create two vectors, m vector objects, and pass just information of every component x, y, and z and side. As you see here, we have our old two vectors, and now I just get the position of this locator with xform command. You see, I just take this guy and I have it all the transformation inside of position variable, and now I just create the first vector here, and if we take another one and just execute this code again, we have the second vector. And if you see, using the dot, we can just print the values of each vector. As you see, for example, result of a epsilon here of this vector, I think, yeah. You see the a and epsilon is 2, and if I just write the x here, we're getting 1. Okay, we have two vectors, and as I mentioned before, all the operation we done normally here we can do with m vectors in simplest way. If, for example, I would like to add to b, as you see here, we have some addition here of the component, and you see it's very simple here. Just take these two values or vectors and add them together to get another vector. And as you see, if I get this and I just create new locator here, as you see here, I just take these guys here and put inside. As you see, I just create new locator with the 3 components here as a translation, and you see we have now this vector is multiplication. If, for example, I take this guy and just move them here, you see they have this vector. We can subtract the vectors. You see, if I take this guy, just execute on take the value of the m vector object and put it here. You see, you got now another object here, and the same here. If you see, if I take this guy here and we get this point. Okay, now we can do the multiplication. If you see, we have a vector a here. I just take this guy away, and we have a vector here, the vector a, and I can just multiplicate. And if I take this variable here and put inside this code here, you get, oops, oh, this is matches object locator 4. Okay, sorry, I have to execute all. And as you see, we have now the new vector here. Create curve tool. Curve tool. and we have the multiplied magnitude of this vector, of new vector. Okay, for getting the length of the vector, we use the module length of, for example, of this vector A here. We can just execute here, and you see if I take now the result here and put it here. Oops. Now you can see if I take my measure tool and just measure the distance, you see we have the length. I think that's it for our 3D explanation of 3D vectors. And in the next tutorial I will show you how I built the tool that I showed before. See you later. Now let's build a tool. I just go through all lines here, line by line, and explain what each line does. At first I begin with a window creation. As you see here, I use the window command for the checking of existence of the of this window. If this window exists, I just delete this window. If not, I create one. I show the window with show window command, and we have our buttons, float slider inside. For having them inside a window, we need to have the column layout. At first I create a column layout. After I put some text information how to use this tool. After I have the empty text as a separator, then we have the float slider group with max and min value and default value 4, and we have the button that execute this function. All information about these commands you can find under Maya scripting reference. As you see, if we go to the panels or film controls, you see here we have everything: layouts, menus, controls, and you see here we have the float slider group. If you click on it, you have example here, and you see how to use this command here. As you see, if you press this button, it executes this function. This function is defined on top. You see here SOS position pole vector control. It takes one argument, distance. This distance argument is needed for placing this control object as a distance from elbow to the control object here. At first I create M selection list using get active selection list. I put all selected object in a viewport inside of M selection list. Then I create backpath list, and now I just get the number of the object inside of M selection list, and I just iterate through all objects with this index. For each object I create MDAG path and take the MDAG path from my M selection list with this index and put it inside my new created MDAG path. And after I just append every MDAG path here created inside of these variables. Now I have all the paths for the objects in these variables. Then we need some vectors to make some math operation with this, and therefore I create 3 m vectors, one for shoulder, the second for middle one for elbow, on the third for A is for wrist. And as I mentioned before, for manipulating objects through the MDAG path, I have to have MFN function sets. And you see is the special type of MFN function set. The name of this function set or of this module is MFN transform. And for every object that I want to have to be manipulated, I create the function set. One for a shoulder, one for an elbow, one for wrist, and one for pole vector control. And I just pass the DAG paths, or I link the DAG paths through the DAG paths this object with this function set. And now I can, through this function set, manipulate the objects. As you see, now we are starting to manipulate the object. We have now the function set. On this function set have the modules. If you see here in a help, if we go to my developer help, under MFN transform, as you see, we have it in space. What is this? MFN transform. Okay, so you see, you can put it just get here with a search, and we have MFN transform. And as you see here, we have the bunch of the modules here, and we have 2 of them, one for getting information and one for set translation. We get translation and we set translation. At first, we have to get the position of every object here. We have shoulder for B, M for elbow, and A for wrist. And we're just getting information and put the result of this module. And you see that gives us, if I take this, that gives us returns the transforms translation as an M vector. As you see, we just take the result of this module and put it inside M vector. And therefore we're creating the 3 vectors here on top. As you see here, it takes one argument, the space. And if you just click on it, you have some arguments here. And the number we need is 4. It stays for world space. And now we just say we get the translation of world space of this object, because we make a MFN transform function set, and just get the information and put this information inside of this M vector object. I'll do it for elbow and for wrist. Yes, we have three vectors here. I just show you what we've done now. We're just getting the position here and create the vectors. Okay, I just create the first vector. This is the vector B. I create now the vector A. I just take it. First we have to get E, enter. This is my, sorry, B. It's gonna be A, and we have the middle one here. I just press here and here. This is our M. Okay, now we have these three vectors. The next we have to do some math with vectors. I explain you line by line what I do here. What have I done? At first, we create a new vector by subtraction B from E. We take the B, you see here. I just move the pivot point and bring it to the E, to the A. And we get now a new vector here. If I show the component of this shape here, now I just can create the lines without locators. Okay, we have now the C vector, and as you see here, we're multiplying C with a 0, 5. We shorten this vector to its half. Okay, how can we do this? I just take this guy, go to curve, make rebuild curve, and say that the number of spans 2. And if you see, if I show now the components, we have a middle point here. And now I just can create a vector. I just take this guy and create. You can also use the method that we seen before, using this method with locator, but I think it's enough. I just take and just snap this guys here, and you see we have now the new vector D, and now we can hide the vector C or delete it because we don't need it anymore. I just take this guy and bring it back. Okay, now we have the new created vector D. After, I just add D to B. I just take this guy and bring it here. I will hide my I key, and you see now we have a new vector here. That will be vector E. Oh, enter E. Okay, we have E. Now we just have to create this vector here and just multiply it with a distance to get the position of this control object. How can we do that? You see, the next we create the vector f, and we just take the new created vector e, and subtract it from m. How can we do this? Okay, we just take the e, as you see here. I just take my pivot point here, and I just take the end of my e and put it to the end, because we're subtracting. And you see we get a new vector. I show you now here. I just take this guy, and we're getting the new vector here. And this vector is f. Okay. And the next, we create the vector p. We just take vector f and bring it to the vector e. This is my vector e, you see here. And as you see, oh, I have some, this is my vector m. This is my vector e. This is f. I'm looking for my e vector. That's an e vector. Okay. And as you see, we that's a little bit strange, this vector. Because okay, I know what is it, because we have to put this guy here. Okay, that's now makes sense. Okay, we just take this guy now. You see here, just ignore this distance. We just put f and put it here. And as you see, we have now the new vector. We multiply and now this vector if I multiply it with a distance, it will be longer. As you see here, if I multiply it by 2 or 3, this will be define the distance. This will be a definition of the distance from elbow to my control object. Okay, that's the math inside, and you see we have now, if you get this point here or there, you can create a new vector for defining this position. And this position we need for transformating or translating of our pole vector constraint. And you see we use here the set translation module of the same MFN function set. If you see here, we have set transform. set translation, sorry. And it takes two arguments, trans and space. Trans is m vector, and the space we, as we mentioned before, we need here 4 for world space. Okay, now we just take the pull vector control MFN transform function set translation module, and put this value here as a vector, and put the 4 here as the space. Okay, that's it. And as you see now, if we take away all these guys here, and we just execute this command, we get our tool here. This tool says select. I just put this here. We select our shoulder, elbow, wrist, and pull vector constraint. The distance you can define here. I just put 4 here. Just, global name X is not defined. We'll look for, maybe I make some changes here. You see now we're looking for okay, as you see, I pass here some wrong values here. I change it, and you see now if I press here, we get our pull vector control position. And if I take my pull vector control followed by I key and make now my constraint pull vector, you see we have no flipping. Okay, thank you very much, and I will see you in another tutorial.